Alright, in this short video I'm just going to be having a look at what to look for when you are required to integrate quotients. So quotients, of course, are a division where you have a top line and a bottom line, or another word for it would be an algebraic fraction. So the first question you should ask yourself, I've got it written there, is the top line the derivative of the bottom line? So let's have a look at an example of this. So we're going to have 2x on the top, and on the bottom we've got x squared plus 6. Alright, so the question is the top line the derivative of the bottom line? And yes, it is. In this case it is an exact derivative of the bottom line. So derivative means when you differentiate it, that's what you get. So the differentiation of x squared plus 6 is 2x. So we know now that this is going to be a log, because when we take the log and put it in the absolute value, because remember logs cannot be, you cannot take the log of a negative number, and so the top line is a direct derivative of the bottom line. When you differentiate back to check, you go 1 over the thing in the bracket, which is x squared plus 6, times the differentiation of what's in that bracket, which is 2x. So there's the first example. It's not always an exact differentiation. So let's try a second example where we're going to integrate 6x squared on the top, and on the bottom line we have x cubed plus 4. Now when we ask our question, is the top line the differentiation of the bottom line? Yes, it is, because we get a 3x squared on the bottom line when we differentiate this, 3x squared. And so you can see that the powers of x line up. So we've got the right power, and all we have to do is make an adjustment with a constant. So the answer to this one would be equal to log of the bottom line. And when we differentiate with what's inside the bracket there, or inside the absolute value, we'd get 3x squared. We've got a 6x squared, so you make a constant adjustment, so it'll be times 2. And of course, make sure you put your plus c on the indefinite integrals. Just do a check on the side to make sure you've done it correctly. So it would be 1 over, when we differentiate back, x cubed plus 4, times the differentiation of that number, which is 3x squared, and then of course we've got the times 2 which we had at the beginning. All of that gives us our 6x squared all over x cubed plus 4. Right, so that's how you do those ones. Let's have a look at the second question you should ask yourself. The second question you should ask yourself is, can we split the fraction? So we want to say, can we split the fraction, the algebraic fraction, into integratable parts? Right, let's have a look at an example of what one of these might be. Sometimes you get them and they look quite complicated. Let me change the colour. We're going to go x squared plus x divided by the square root of x. Right, whenever you see any surds, do make sure you change those into index form. So x squared plus x over x to the power of half. Now, can we split the fraction into integratable parts? Yes, look at this. We're going to get that bottom line and put it under each of the top line bits that are added or subtracted, in this case added, and then you use your power rules. So we have the same base number. When you divide two numbers with the same bases, we subtract the powers. That gives us x to the power of 3 over 2 plus x to the power of, so that's x to the 1 minus x to the half, because that would actually have a power of 1 on it. So that gives us x to the half. So this is what we're needing to integrate, and they are just polynomials, nice and easy. Increase the power by 1 divide by the increased power is the same as, so dividing by 5 over 2 is the same as timesing by 2 over 5. So I'm just going to go straight and put the 2/5 in at the beginning. This one here, increase the power by 1, that gives us 3 over 2. So do use your calculator for these just to double check that you're putting in the correct ones. It's so easy to get those fractions wrong. So when you're increasing the power by 1, you just add 1 to your fraction. We get 3 over 2 and then divided by 3 over 2, which is times 2/3, same thing, plus c. And now we're done. Right, so that's those ones. So look out for that as the second thing to look for when you are looking at integrating a quotient. The third thing to look for is the top line and the bottom line linear functions. So we are the top line and bottom line, the numerator and the denominator, linear functions. So linear functions are mx plus c. So you'd have a format, you'd be integrating ax plus b divided by cx plus d. So you can see the top line here has got an mx plus c format, and the bottom line also has an mx plus c format. Let's have a look at an example of this one. If we were asked to integrate between 5x minus 3 over x plus 3, we're actually going to do a definite integral for this one. So we are going to integrate between 2 and 5. Alright, so we can see the top line is mx plus c format, and so is the bottom line. So when we have this, there's two things we can do. You can do a division, so 5x minus 3 divided by x plus 3. When you do these, you just look for the first term. So see that one there? We say how many times does x go into 5x? Well, it will be 5 times. And then you do the multiplication. 5 times x is 5x. 5 times positive 3, so we're doing the multiplication across here. So that will be plus 15. We're going to subtract it. 5x minus 5x eliminates the x's. Minus 3 minus 15 gives us minus 18. So this gives us a mixed number, if you like, of 5 plus or minus 18 over x plus 3. So that means we would be integrating 5 minus 18 over x plus 3. So that's one way of doing it. There's another way of doing it, which you might prefer. So that here is the long division way. The other way is to take the bottom line and put it up the top, and put a 5 in front of it because we need 5x. So it's all going to be over x plus 3. We're going to just rearrange it. We're not going to change it, we're just going to rearrange it. So the top line would now give us 5 times x. Put that bracket back. Let's have a look. I had this the other day. Let me just reopen that. It jammed on the changing the tools. Let's have a look. Trying to rub that out. There we go. Alright, so let's go back to this. So what I did is I took the bottom line from here and I wrote it on the top line and made an adjustment to the number in front so that I would get a 5x. But I also get a plus 15. I don't want plus 15, I want minus 3. So in order for the top line to give us a minus 3, I need to minus 18, because 15 minus 18 will give us our negative 3 that we require. So just make an adjustment. So then we have 5x plus 3 over x plus 3, because that's the fraction. We're going to break it back. So it's sort of like, for years you've always been putting the fraction together. Well, we're actually pulling the fraction apart. And the second part is this. I'm going to put those brackets in. Minus x plus 3. We can now see that these two bits cancel off. I'll use a different colour. I'll cancel them like that. So x plus 3 on the top and x plus 3 in the bottom form a 1. So what we are left with is integrating 5 minus 18 over x plus 3 dx. Now we're going to do the integration. 5x minus 18 log x plus 3. And when you differentiate back, you just get a 1, and the 18 is there for the adjustment. Now, we're going to do a definite integral. I've got to keep writing the numbers in. So this one here was between 2 and 5. So once you've done your integration, what you need to do is to draw square brackets and put the limits of the integration on there. This would be 5 times 5 is 25 minus 18 log of 8. Now do make sure you bracket that first one, because then you're going to subtract, and you've just got to be so careful about your signs, because there's a negative in the middle and you've got to be careful that you don't subtract it, because you'll end up adding it. So 5 2's are 10 here, minus 18 log 5. And you see here what I was talking about, this negative and this negative will actually give you a positive. So just be very careful. You may just wish to put it in your calculator exactly like that to get your answer, or you might want to do one more step. And of course, actually we won't need to put we know that 8 is a positive number, so we can just write 8 in there, and then we're going to add 18 log 5. Put it in the calculator, and what you get is, so I've done this earlier, the answer is 6.540 square units. So you can go units squared or square units, and that will be your answer. Now remember that you can check just to make sure you didn't muck up the signs in the run menu. So menu number 1, you go options, the option key, and then F4 for calculus, then F4 again for the integral. Put in the unintegrated, the first one. You can actually go right back to the original, right up the top here. I'll put an arrow there. You can go right back up to there and put that into your calculator and put in your limits, and you will get the answer, 6.540 to 3 decimal places. Now just remember, when you are putting it in your calculator, that the limits go the other way around, so you will be putting in the bottom limit and then the top limit with commas in between them. So make sure you ask me about those if you have trouble doing that. Alright, so that's one example. Let's have a look at one more example of this. So we're going to integrate this time 8x plus 7 divided by 4x plus 3. So once again, the first question is the top line the differential of the bottom line? No, it is not. The second question is, can we break it into fractions so we can integrate each part? No, we cannot. So looking at this one, it is one of the ones where the top line and the bottom line are linear equations. So the top line's in mx plus c format, and so is the bottom line. Right, so what we need to do is, let's do the method where we go, we'll do the long division, 4x plus 3, sorry, we'll do the long division first. So it's 8x plus 7 divided by 4x plus 3. Right, how many times does, now remember what I said, you just look at the first one. How many times does 4x go into 8x? It goes in twice. So then you multiply it across, so 2 times 4x, we get 8x. 2 times 3, we get 6. You subtract them. 8x minus 8x, no x's, so that's eliminated. 7 minus 6 gives you 1. So our answer is that this gives us our whole number up the top. Whole number there. So we've got 2 plus, and what's left over is 1 over the bottom line 4x plus 3. And that is therefore what we'll be integrating. Alright, so that top line there, the number you get there is your whole number, and what you get left over at the bottom is your top part of your fraction, and this number here goes on the bottom line. The second way of doing it is that we take the bottom line to the top. It's all going to be over the bottom line, same bottom line. And then we need to make an adjustment in front of that bracket. In this case it will be a 2, because we're going to get 2 times 4x giving us 8x, 8x plus 6. We're getting a plus 6, we want a plus 7, we need to add one more. And so our answer is going to be 2 times 4x plus 3 over 4x plus 3 plus 1 over 4x plus 3, and that is what we are integrating. Well, these are going to cancel out, and therefore be integrating 2. I'll do one more line for you. Answer is 2x plus log of 4x plus 3. Now, just make sure that you're going to differentiate back to check. So what is this going to be? Integrating the log of 4x plus 3, I'm just going to do it on the right hand side, is 1 over 4x plus 3 times 4. So in fact we need to make a quarter adjustment, and so there's going to be a quarter in front of that. So just watch out for those sorts of things. Always do differentiate back to check that your constants are correct. So although we split it up and we've got a 1 at the top, it is integratable, but you still have to make that correction of a quarter for it to be correct.